If it's another rainy day, we don't send out the drone because that's how we get short circuits and destroy $400 worth of technology. So we're going to give it a break and try to send it out tomorrow. I think the weather will be better. In the southwestern U.S., stagnant weather pattern, there's that stationary front. This is the backside of that polar air mass. We've had that ridging extending all the way down into Texas from the Great Lakes. That's just a big blob of cold air. And we've had the southwesterly flow on top of that. We already know that because we've talked about that the past few days, and that's given us isentropic lift. And let me show you a product that helps us diagnose that. One thing we could do is a cross-section. This runs from about Houston up to Des Moines, and we've got it plotted here. See, there's Houston, then we get into Arkansas, Oklahoma, and then Missouri. So if we plot potential temperature here, you can see the cold air. This is, these plots here, this is potential temperature, so this is temperature that we would have if we moved the parcel down to pretty close to sea level. And what we notice going left to right is colder values in the north part of that line and warmer in the south part. And so we can kind of visualize the cold air just kind of sitting there near the surface. And if we have any southerly flow, it's going to tend to want to conserve its potential temperature, and it's going to ascend, which means clouds and rain. This is wind along the plane of the cross-section. So we can see that there is a southerly component to the flow, and that's helping to produce those clouds from Texas all the way up to Kansas. And another important contributor is relative humidity. You can see that it's pretty humid. We've got 70% relative humidity all the way up to about 750, 700, which is about 10,000 feet or so. So we got all the ingredients there. We've got wind component going in an upward direction. The isotropic surfaces slope upwards, and it's already humid, which means we don't have to ascend very much to get saturation and rain. So no wonder it's kind of cloudy. And there's another cross-section from about Del Rio up to Kansas, pretty much the same thing. You can see that moisture there up to about 5,000 to 7,000 feet. And these are capabilities that we have in digital atmosphere. Now, College DuPage, they do have a site that's got a similar thing. You can use this to kind of cross-check your information. This is a cross-section from Del Rio to Green Bay, and you can see that it shows kind of the same thing. Presence of cold air, and then the air becomes a lot more dense up there near the Great Lakes. One problem, though, that people don't really think about is these wind plots. These are not wind components, but these are like relative to true north. In other words, what you see here is not wind flowing from south to north. This is a westerly wind. So it can be pretty hard to resolve that data to the page. So I think this wind plot information is kind of useless. You really need to be looking at components going left and right across the page like that. So I would disregard the winds or kind of use those mentally. You know, you'd, like for example, here you see the south wind. That's going to be aligned pretty much with the cross section, so you can pretty much assume that it's going left to right. And if we had a north wind, if we had a plot that looked like this, I would say the opposite thing. That would imply that the air is flowing right to left. So orienting yourself with the wind data is very important, and it's often overlooked. Anyway, that's kind of a technical tip. We'll kind of get back to the presentation here. And out in California, the weather is starting to become a little bit unsettled, and you can see that easterly flow through Los Angeles and the Central California coast. We've got a barotropic low offshore. That's kind of a cutoff low, and that's going to be approaching Southern California over the next day. And we should see conditions start to go downhill there. In the southeast U.S., we've had some frontalysis of that stationary front that extended from the Carolinas to Alabama. That's kind of drifted very slowly southeast, and it's located there in the Columbus, Georgia area. Warm front all the way back to Savannah. So we're getting a little bit of overrunning over that frontal surface there, northern Georgia down to Alabama. There's that cold, stagnant air across Texas, Arkansas, and Oklahoma, and the northeast U.S. under the influence of that massive Great Lakes high moving into Quebec. Continued northerly flow in places like Ohio, Pennsylvania, and Indiana. Little weak Alberta Clipper coming through the Fargo area. There's that front running from about Fargo out towards Duluth. And in the Pacific Northwest, a very quiet day. Very weak high pressure pushing out of Montana, driving that little Alberta Clipper there in the Dakotas. And the west side of that high puts that area under warm air advection. So the general pattern is kind of like that. And they're just now starting to deteriorate just a little bit there in the Washington, Oregon area. Probably as the next wave out of the Gulf of Alaska approaches. So overall, a very quiet weather pattern across the country. There's our cutoff flow there off the California coast. Looks like we've got some thunderstorms, maybe about 150 miles offshore. I would expect continued development on that, and we may see some of those showers starting to work eastward towards southern California. So today could get a little bit more interesting. Out in Texas, some very extensive stratus and fog goes all the way down to Mexico, back up to the Concho River Valley, and then up to Kansas. Extensive stratus there, so that's that isentropic lift. And on top of that, looks like we're getting some cirrus as we get some height falls or maybe some jet stream interaction from the west. Some pretty impressive Lee Mountain cirrus, see right there around the Clovis Capulan volcano area. So that's certainly a good indicator of very strong winds approaching the area. As far as deep convection, we're pretty much done with that, but there's a little outgoing cluster there in the St. Louis area. Most of the rest of what we have across Texas is just stratus, and I would expect that to start eroding over the next day or so, unless we get some strong return flow developing. In the southeast U.S., we got a little cluster of storms moving through the Montgomery, Birmingham area. Can certainly kind of trace out where the fronts are. So that corresponds fairly well with our surface analysis. And then out in Florida, still under that stagnant late spring weather pattern. In the northeast U.S., looks very frozen up there in Canada. You can see all those lakes very clearly on the satellite imagery. Fair weather across much of the northeast U.S., but out to the west, here comes the next weather system. Good upper level lift approaching Indiana and Ohio. For the north central U.S., we know that we have fronts kind of set up like this. So this is our next system coming out of Canada, probably low pressure right there, and there you can see the wraparound of the cloud system right there. Most of the heaviest lift is going to be north of Minneapolis up to Duluth, so any potential for snow showers or rain showers are going to be mainly in that area. And of course that'll likely continue moving to the east as the day goes on. And a nice day in the Pacific Northwest, but now we can start to see some changes. See up there in the top left corner, big shield indicating very strong baroclinicity, probably a major shortwave moving out of the Gulf of Alaska. To the west of there, looks like some very dense multi-layer clouds, probably nimbostratus, altostratus, and then back in behind it, some signs of very intense cold air advection. So this looks like the next front barreling southeastward towards Vancouver and Seattle. See if we can take a closer look up there. Yep, there it is. There's that next system. You can see some strong rotation right there, and There's that next front, and back in behind it, very strong cold air advection. We can probably look at that on the Canadian surface analysis. And there it is. I would say this is probably a little bit further out ahead, but in the center of that low just off the coast there near Juneau and Ketchikan. And this is their take on the California system. That's interesting. They decided to go for a front going from San Francisco to Nevada to Las Vegas. I'm not sure I agree with that. I'll definitely take a closer look and see if that might be the case. Then offshore cold front. Okay, so yeah, let me see what I think about that analysis. Well, here's the GFS chart. Do I agree with a warm front up here? No, it's not supported by the thickness field. The better thickness values are way down to the south. So what else can we look at? Maybe could be an elevated front. Well, we don't have a 700 to 500 thickness chart or anything like that, but we can take a look at maybe the 850 temperature and winds. Got to look at that temperature field. Let's check it out. 850, this is up about 500 feet. Any support for a warm front up here? No, not really. I mean, if I had to go just by this, see, your stronger gradient is way down here. So this indicates maybe kind of an arrangement, something like that. Okay, let's go to 700. I mean, there certainly could be an elevated front. No, there's no support at all up here. The gradient is way down here. It's as plain as day. Okay, so using that, I would probably start off with this little thermal ridge right there, go by that, and put the warm front on the south side of that gradient and the cold front on the south side of the gradient also, and then kind of bring the occlusion up like that. So that's right there. That's a possible solution. But keep in mind, this is 700. This is not what's going on at the surface. Could be a slightly different picture, but the fronts at the surface will kind of be in that same area. So we need to be looking definitely south of Southern California. So where are we going to put the fronts? Well, I'm going to go with something like this. Bring it up into the thermal trough as best as I can and then back into the low. I think that's the configuration we have today. And then a lot of those showers we have off the coast, those are probably in this warm advection area north of the warm front. And there's probably a little bit of a little inverted trough off the coast, certainly. So that's what I'm thinking we're looking at for California. For this evening, cutoff low approaching the California coast. Showers will be approaching the coastline, but they'll probably end up shutting down as evening sets in, but looks like there's probably going to be some destabilization over the mountains too. So probably a pretty interesting sky there for the LA area later this afternoon. Front's probably looking something like that down there. And then elsewhere around the country, this seems to support some northward advance of the warm front. See that there? So the warm front will be lifting north. Looks like another system up there in Nebraska. I'm not sure which way that's headed. And then in Georgia, looks like that low pressure area moves very swiftly off the East Coast. A little bit of an inverted trough there in Ohio and Indiana. That's probably that outgoing system. And then another low pressure system up in British Columbia. That's the one coming off of the Pacific Ocean. Then for tomorrow night, looks like a warm front there in Oklahoma. Not seeing much northward advance, so I think what happened is maybe for tonight we're having some trouble clearing out that cool air mass in Texas. And then finally becomes reestablished there in Oklahoma. Cold front extending very clearly down into northwestern Mexico. New cold front forming up in Alberta. And our outgoing Midwest system going off the coast there, off of New Jersey. For Tuesday night, Oklahoma system comes together. Very well-defined area of precip out ahead of that. So looks wet in the Ohio River Valley. New Canadian system coming out of Manitoba and Saskatchewan. Wednesday night, the East Coast system moves offshore. New Canadian system coming southward, driven by this 1020 millibar high. I should get my graphics tablet up and working. I think that would work better. But man, look at all this thickness gradient out there in Arizona. So that is certainly a baroclinic zone, and we can also see evidence of a upper level trough there in California. So it's going to be unsettled and showery until that trough axis passes to the east. For Thursday night, that baroclinic boundary looks like that's starting to see some frontogenesis. New system coming together there in southwestern Kansas, extending all the way up to Indiana, where we have a wave up along that boundary. Yeah. Okay, viewer messages. This one's from David Moore. You mentioned the terrain backdrop that you use on Digital Atmosphere. Is that in the place files or something that you downloaded? Yeah, we're talking about Digital Atmosphere under the data menu or the map menu. Import planetary map. Yeah, I've got some files that I use here. Some of them are generated. I believe that the newest versions of Digital Atmosphere do include a planetary map under the planetary directory. So that should be like, with your styles tutorial, and should be in that planetary directory. There should be one map in there. If not, you can let me know. Now, if you want to find where to get maps, put in planetary texture map in Google. Yeah, like you see here. And you should find some texture maps. And I'll tell you what to look for. Obviously, we don't need Jupiter or Mars. But let's see, where's Earth? Yeah, there we go. What we're looking at is JPEG maps. You need a JPEG, and it's going to look like this. It's going to look rectangular. So you're going to look for a map that looks like this. You save that to your directory, and then you can import it using that import planetary map feature. So any of these will work. The higher resolution ones are preferred. See this ultra resolution 8K? That's going to work even better. You can see there's more detail there. And the one that I use is 16,000 pixels. And that's how I get these results. So look around on the internet. There are sources out there. That's one. Do not use maps like this. See how they're kind of distorted to kind of form a projection? Don't use maps like those. Those are not going to work. So get a copy of the Digital Atmosphere Manual 2. That should be installed with your newer versions. You want something that's revised 2018 or 2019. And you can see that there's a section for Import Planetary Map, and that'll kind of give you some information. Shows you need the equirectangular projection, and it needs to look like this right here. It needs to be set up just like that. Can you spend a bit of time explaining how to read Sharpie? And we're actually talking about Sharpie, the skew-t drawing algorithm. That's what they use there at Pivotal Weather. And that's kind of like a little module a lot of these websites use. Yeah, we'll definitely go over that, but we're going to need to do that on a severe weather day where we actually have stuff to look at. So I will keep that in mind. That's a great idea, and I do agree there's some things that we should go over. And that's about all I got for today. I appreciate you all watching. Hopefully we'll see you all tomorrow. Bye-bye.